Hello, Venkatesh. Welcome on to YourPedia. Let's start your snap interview for DRDO on the subject control systems.
Okay, sir.
What is the difference between controller and compensator?
Difference between controller and compensator is that controller for building controller we need active elements. For compensators, just RC components. It is okay for building compensator.
Okay. So, which controller is used to improve transient response?
For improving transient response, we need proportional and derivative controller.
Okay.
Derivative controller. You can say.
Derivative controller. Fine. See, I need a phase angle of 90 degrees.
Okay.
So, I have elements like RLC with me.
Okay, sir.
You design one circuit in such a way that from input to output, I must have phase displacement of 90 degrees, exactly 90 degrees.
With a single pole, we can achieve maximum 90 degrees phase lag.
With what?
With a single pole, sir.
I need a circuit for that. Circuit.
Okay, sir. Wrong.
Yeah, please.
Sir, this circuit is simple
Okay.
RC low pass.
So it is giving, I want 90 degrees. Select the values of R, C, and omega. I want angle as 90 degrees. Tell me what are the values of omega, R, and C? Exactly 90 degrees I need. I need plus 90 degrees, not minus 90 degrees.
Uh, 90 degrees theoretically we can achieve, but practically components limitation comes. Component sizes.
So I need, yes, I need exactly 90 degrees. You take any number of resistances, any number of capacitances, I don't mind, but design the circuit.
For positive phase, I can take high pass filter reverse. Just now I took low pass circuit. Again I have to draw. So this circuit I am taking.
If that is also, what is the angle you got?
For 45 degrees, I am designing first one circuit.
Okay.
If I design for 45 degrees, then omega RC will be equal to 1, sir.
No, my question is about, I need 90 degrees. Nah? I don't want 45 degrees. I need 90 degrees exactly.
Sir, I designed a circuit for at 1000 radians per second frequency for 90 degrees. For 90 degrees.
Okay.
Here it is.
So tell me, with one RC network, is it possible to get 90 degrees exactly?
No, sir. Practically not. Values, feasible values we cannot get. So I designed for 45 degrees.
You designed for 45 degrees, but I want 90 degrees, then what to do?
Two circuits we can cascade.
Two circuits we have to cascade. Okay, fine. Yeah. See, take one transfer function. Open loop transfer function.
Okay.
K by S into S plus 1 into S plus 2.
Okay.
Sketch its root locus. Sketch its rough root locus.
I'm calculating the angle of asymptote.
Not required, just angle of asymptotes. Is it required to calculate? There are three asymptotes, na?
Yes.
If there are three asymptotes, the angle of asymptotes will be
Yes.
2q plus 1 into 180 by
2q plus 180 by 3.
3, right? So 0 into 180 by 3.
60.
Sorry.
60.
1 into 180 by 3, 3 into 180 by 3, 5 into 180 by 3. Plus 60 minus 60, 180. That's
Yes,
all.
Yes, sir.
Then you draw the root locus. Yeah, fine. See, the transient response of the system is going to depend on the pole's location. Now, we will get all possible transient response which are present on the root locus, right? Root locus means movement of the roots when the value of gain k is varied from 0 to infinity.
Yes.
If I want transient response because of the pole which is not there on the root locus, what I have to do? You do one thing. Location. You do one thing. Draw a straight line from origin onto the root locus with some angle of 45 degrees to the left side. In the second quadrant, from the origin towards left side, draw a straight line. Yes. Now, see that straight line is cutting the root locus at some point, na?
Yes, sir.
See, that point is a root. That point is the root of the characteristic equation, or that point is there on the root locus. So yes, that is a pole location. I'm going to get some transient response by looking at the point, I can say, by looking at the root. But I want transient response because of the root, which is not there on the root locus, but is there, but that is there on the straight line somewhere. Okay. Then what to do?
Like this point you asked.
Yes. I want a transient response to the point which is there at that location, but that is not a pole, or that is not a root on our root locus. Then what to do?
You can design a lead compensator.
Lead compensator. So what lead compensator will do?
It improves the transient response. So that's what you are asking.
See, I'm not asking about the improvement of transient response or improvement of the transient response. I want some transient response, okay, which is due to a point which is not there on the root locus. Then what will do?
Let us consider this. Our desired pole is what now we are intended. To pass in root locus in that pole. The one condition we took, that angle condition in that pole, at that pole.
Okay.
So by satisfying that criteria, angle criteria, I can add a pole there. For example, if I take a lag compensator, by satisfying that angle condition, we can get its pole. Then,
okay. So overall, you mean to say that with the compensators, you are going to achieve the transient response, right?
Yes, yes.
Is it not possible with controllers?
Controller also it is possible.
So if you look at there, we have a point where my straight line is intersecting with the root locus. Okay. There, give me the value of time constant and peak overshoot. And another point, what I selected,
okay,
on the straight line. There, what is the time constant and peak overshoot? Take those points as 1 and 2. The point where the root locus and the straight line is intersecting is point number 1, and the point related to which I asked about transient response, you selected one as point 2. Then give me the time constant and the peak overshoot about those 2 points.
Peak overshoot will be same, sir, because zeta is same.
Okay, then what about time constant?
Time constant. For second point, time constant will be less.
Okay.
The
Fine.
first 10 years.
Okay. So let me give you feedback, Venkatesh. Your approach is okay, but a little more, I can say, like analysis is required from you. See, I asked about, I need exactly 90 degrees. Again and again, you are showing only one circuit. You are saying that you designed for 45 degrees. So in the last, you said that yes, connect two circuits in cascade to get 90 degrees. That is absolutely fine. Okay.
Okay.
So take the question in a proper way and try to work on that direction.
Okay.
Okay.
Okay. Okay.
And the main purpose of controllers and compensators is to improve the steady state response and transient response. Okay. So the last question what I ask is if I want the transient response of because of that particular point which is not there on the root locus, there are two ways. One is completely you redesign the system such that your root locus is going to be there, or you add some controller to that such a way that your root locus is going to be there at that point of our intention. Okay. So yes, fine. Your approach is fine. Okay.